Okay, good morning. Okay, good morning, Umang Jaisal. Am I audible?
Yes, sir.
Okay, so just wait, I am starting.
Good morning, sir.
Yes, good morning, Ponam. Okay, just wait a few seconds, then I will start. Okay, so let's start. So good morning, everyone. So today we will discuss our rest of the topics are available in our jet transform module. Okay, so the previous classes we have discussed these are the jet domain analysis of the different terms, that is the impulse sampling method, how it is calculated. Then we will discuss the data hold circuit, what is the data hold circuit and what is the functions of this hold circuit and how it is derived. Okay, and another one also important terms, that is a zero order hold, that means the transfer functions calculation using in the discrete time control system. Okay, and using these terms we have to cover another one, that is the pulse transfer function. So today we will discuss the first pulse transfer functions. So my whiteboard is visible, everyone?
Yes, sir.
Okay, so this is the pulse transfer function. So first of all, you know that is a transfer function. So transfer function, it is a ratio of the output to the system to the input of the system. You know. So here we have to use these transfer functions for the continuous time systems, and it is basically relates to our Laplace transform of the continuous time output. Okay, so the transfer functions for the continuous time system, continuous time system relates the Laplace transform, LT means that is the Laplace transform of the constant, so continuous time output to that of the of the continuous time input, while the pulse transfer, transfer function relates the jet transform at the sampling instance to that of the sample input. Okay, so this is the basically first introduction about the pulse transfer function. So this transfer function for the continuous time system. You know that continuous time systems we have discussed in previous classes. That means we have to express that is h of t, continuous time system. So it is related to the Laplace transform of the continuous time output to that of the continuous time input signals, while the pulse transfer functions relates the jet transform of the sampling instance. Okay, so you can see when you have to consider for the pulse transfer function, it is relates to the jet transform method of the sampling instant or inputs, sampling input, but when you have to consider for the LT, that means the Laplace transformations, it is basically uses for the continuous time system of the input to the output system. Okay, so now before going to the details in the pulse transfer functions, we have to know one another terms. This is very much related for this, that is convolution summation. Convolution summation. So ये summation मतलब ये summation क्या है? That is the addition or two or more inputs in one. So this convolution system, it is basically a response of the continuous time system. It is driven by an impulse sample signal. Okay, these impulse sample signals we have discussed in previous last classes tomorrow. Okay, so this is the basically a train of impulse. Okay, train of impulse means that is a continuous time signal. You know that we have to apply the different inputs, that is the changes of the different samples input, that is the t, 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 and it is basically across in the 0, k is equal to 0, 1 to infinite range of the value. Okay, so these are the basically train of the impulses. So the continuous a continuous time system driven by an impulse sample signal, and you know that this sample signal is basically called a train of impulses. Okay, as shown in the figure, I am drawing in the figure in the next page also. Okay, so this is the basically first continuous input signals. One switch is here also. Another also block it is available. You know that this is the transfer block, that is the GS. This is the input signals. This is a one switch, and this is the input of the continuous time signal xt. And this is the delta t. You know that this is a sample input signal, that is the S asterisk of with respect to the time, and this is the continuous out. This is a continuous output signals. 1 minute. That is also y t with respect to the timing. Another one, this is the another output functions. We have to attach one switching operation from here. So this is another delta t y asterisk of t. So in this figure, this is basically continuous time system, that is the GS. It is driven by the impulse sample signal. So this is the figure of the continuous time system that is GS driven by an impulse sample signal. Okay. So in these signals, you know that is the range of the basically continuous time chain xt, that is equal to 0, where t is less than 0. Okay. So this condition, the impulse sample signal, that is the s asterisk of t, it is the basically input to the continuous time signals. Okay, so this is a basically x asterisk t, this is a basically input to the continuous timing systems, and it is transferred the functions to the gs also, and the output of the system, it is basically assumed to the continuous time signal, that is the yt. This is the output, and another output we have to attach here, that is a sampler. Okay, that is a y asterisk of t. This is sampler out. So basically the output of the yt, that means we have to written here the jet transform of yt is, that is jet transform of y of t, that is also y of z. You know that. And we have to retain the mathematical expression, that is summation of k is equal to 0 to infinity y of kt different k value j to the power minus k. So this is the question number 1. So this is the basically mathematical expressions for the continuous time system GS driven by the impulse sample signal center. Okay, up to this part it is okay, all of you? Now, so in the pulse transfer functions, you know that there are the lots of the ranges available. So continuous time signals, it is basically a well-known fact of the output of the yt. The system is related to the integral part. So now for the 1 minute, continuous time system, continuous time system, it is a well-known fact that the output yt of the system is related to the input xt by the convolution integral. So the equation, that is yt, this is equal to, sorry, this is the integration 0 to t, that is g t minus tau into x of tau r d tau. So this is the basically mathematical expressions. So now we have to consider, that is integration 0 to t x t minus tau into g tau d tau. Okay, so where gt, what is the gt? Where gt is the weighting functions. Is the weighting function. What is a weighting function? You know that when you have to use the continuous time function, there are lots of blocks at a time it is passing. That is the input to the output functions. So sum of block you have to save the system. It is weighting or blocking system. Okay. So this GT is basically called the weighting functions of the system. So in a discrete time system, we have to convolution summations. We have to express that is the x asterisk of t. This is equal to summation of t is equal to 0 to infinity. That is x of t delta t minus kt, and we have to return this in the equation. That is also kt k is equal to 0 to infinity x of kt delta t minus kt. Okay, so this is the basically a convolution summation equations for the discrete time control system, and it is a basically train of the impulses. Okay, because you know that when you have to change the different value of the k, and k you know that is 0 1 2 etc. Okay, so this is the basically train of the equations of the discrete time system. Is it okay, all of you? So it is a train of impulses. Okay, this response anyone? It is clear or not? So now we have to written this equation, you know, that is y of t. This is equal to, I'm written from here because it is very clear. Lots of the input. First, that is gt x0. When that is a 0 less than equals to t and also less than capital T. Again t is changes, then gt x of 0 plus g t minus capital T x of capital T. When I'm written here, that is the capital T less than equal to t and less than 2t. You have to see here changes. First t, then 2t, and so on. So next term, it is also same, that is gt x0 plus g t minus capital T xt. Okay, then the second term, that is plus g of small t minus 2t. Here you can see t minus t, capital T, here t minus 2t into x of 2t. So when that is 2t less than t less than 3t, and so on. This process is continuing, you know that, up to the infinite range. So last term we have to written here, that is gt x of 0 plus g t minus capital T x capital T plus g, 1 minute, that is the dot dot dot, lots of terms you know, that is g t minus kt x of kt, where range is, you know, kt less than of t to the, here that is the k plus 1 into t. So this is a basically called the train of pulse. Okay, that is a pulse transfer functions. Okay, is it okay, all of you? Is it clear? Am I audible?
Yes, sir.
Okay. Okay, so this is basically called the pulse transfer function or chain of impulses. So this physical system, it is a response and it cannot receive the input we have, that is gt is equal to 0. So when that is gt is equal to 0 for t less than 0, or gt minus kt is equal to 0 for t less than of 2t. So now we have to written this equation, previous one, that is yt, this is equal to gt x0 plus gt minus capital T x of t plus g t minus 2t x of 2t plus dot dot dot, I'm written here, that is g t minus kt x of kt. Okay, now we have to written this equation, that is the summation of h is equal to 0 to infinity, okay, or 0 to k, 0 to infinite or 0 to k, these are the same thing, because you know k is the range of the 0 to infinite range. Okay, so that is g of t minus ht and x of ht, where 0 less than small t less than equal to qt. Okay, so this output, the values of the output yt at the sampling instance, that is equal to t is equal to kt, where k is changes, that is 0 1 2 dot dot infinite range. Okay, so now we have to written these equations, that is y of kt, this is equal to summation of h is equal to 0 to k or infinite, these are the same thing, that is g of kt minus ht into x of ht. This is another question, equation number 2, and we have to express these equations, that is h is equal to 0 to k x of kt minus ht into g of ht. This is another equation number 3. So here you can see this is the basically gkt. This is basically called weighting sequence. Is the weighting sequence. Okay, so now we have to summation the equation number 2 and equation number 3. So this is basically called the convolution summations. Okay, so the summation of equation 2 and 3 is called the convolution summation. Okay, so now we have to written these equations, that is y of kt this is equal to x of kt multiplied, that is g of kt. Okay, so this is basically called the convolution summation, and this convolution summation, it is related to the our pulse transfer functions also. Okay, so one graphical form is given here. This is a yt, this is a t. Yt small t. Okay, so the graphical form, you know that this pattern. And so on. So these are the different t. Okay, t, 2t, 3t, 4t, 5t. Okay, this is the 0, t, 2t, 3t, 4t, 5t, and so on. So this is the basically plot of the output to the yt, that is the impulse response, when t is the degree of denominator polynomial functions of the gs. Okay, so this is the basically called the convolution summation. It is related to our pulse transfer functions. Is it clear, all of you? Now we have to draw the equation number. I'm written here. This both equations is very important. Now we have to calculate pulse transfer functions. Pulse transfer function. So from equation, I'm written again equation, that is y of kt is equal to, you know that, summation of h is equal to 0 to infinite g of kt minus ht x of ht, and another one, a summation of h is equal to 0 to infinity x of kt minus ht g into ht. So from these two equations, we have to written, that is equation number 1 and equation number 2. From equation 1, we have y of kt, that is summation h is equal to 0 to infinity g of kt minus ht x of ht, where age is equal to 0, 1, 2, dot dot. Okay, where 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 g of kt minus ht, this term, this is equal to 0 for when h is greater than of k. So hence the z transform of y of kt becomes, I'm going the next page, that is the equation, you know, y of j, this is equal to the summation of k is equal to 0 to infinity y of kt into j inverse. Okay, so when you have to apply this equation in our pulse transfer function, you know that there are the different values it is available for the different sampling input. That is the key changes, you know that. So that's why we have to written these equations. That is first summations. That is equal to, you know that, that is 0 to infinity uh, into a summation of h is equal to 0 to infinity, that is g into kt minus ht into x ht z inverse t. Okay, so first of all, you know that here two summations we have to apply. One is the k is equal to 0 to infinite. First, that is a one transfer function for the pulse transfer functions. Another one, h is equal to 0 to infinite. Okay, so these are the basically two summations of the these functions also. Now you know we have changes these equations, that is equals to summation of m is equal to 0 to infinity, also summation of h is equal to 0 to infinity, that is g of mt into x of ht z to the power minus m plus h. Okay, so we have to change this equation here. K is equal to 0, that is equal to m is equal to 0. So here that is also changes z to the power minus k, that is equals to m plus h. Okay, so now we have to simplify this equation. Summation of m is equal to 0 to infinity, we have separated this equation, that is g of mt z to the power minus m, and another part summation of h is equal to 0 to infinite, that is x of ht into z to the power minus h. So we have to separate this equation. You can see first of all m tends to m is equal to 0 to infinite gmt z to the power minus m. We have to separate from here. Another one, summation of h is equal to 0 to infinite x of ht into z to the power minus of h. So now, because you know that this is a basically called the gmt, these are the functions of the gz, that is the transfer block first. Another one, this is x of ht of z inverse h, this is basically x of z. Okay, and this is basically y of j, you know that. So this is a basically equation number 3. So now we have put here, that is m is equal to, you know, k minus h, and the functions, that is gj, this is equal to a summation of m is equal to 0 to infinity a g of mt into z to the power minus m. This is called z transform of a gt. Okay, up to this part it is clear, all of you? Please respond. Is it clear or not? No one is confirmed. So now we have to make this equation into the transfer function. So first of all, we have to explain, that is yz is equal to gz into x of j. So we have to written these equations, or gz, this is equal to y of z by x of j. So you know that in our control system we have to calculate the transfer functions. Transfer function, it is basically ratio between the output of the system to the input of the system. So here you can see this is a basically transfer block. Okay, this is a basically output of the system to the input of the system. Okay, so uh, this ratio of the output, that is a yz, and input, that is a xz, it is basically called the pulse transfer function. So I'm written here. So zz is given by the equation. This is equation number 4. Equation 4. The ratio of the output. You know the output, that is the yz, and the input, that is the xz, is called the pulse transfer function of the discrete time system. Okay, so what is the block diagram? You know that this is a input, sorry, this is a first block, transfer blocks, you know that, and this is a output. So this is a gz, you know that this is the input xz, and this is the output y. Okay, figure, that is a block diagram for a pulse transfer functions system. Is it clear, all of you? This is a very much important questions for your semester. Please note down it, everyone. क्वेश्चन ऐसे आप लोगों को दिया जाएगा, व्हाट इज पल्स ट्रांसफर फंक्शंस, एंड यू हैव टू डिराइव द ट्रांसफर फंक्शंस फॉर द पल्स ट्रांसफर फंक्शंस. ओके, ऐसे आप लोगों को एक बड़ा क्वेश्चन आ सकता है, मार्क्स ऐसे 5 या 5, 7 और 10 भी आ सकता है. ओके, ऐसे बड़ा वाला क्वेश्चन. So how it is derived, I am solved step by step. So please go through the previous slide. Okay, I have uploaded the class note in your Google Classroom. Please read it carefully. This is very important topic, that is a pulse transfer function. And this pulse transfer function you have to solve before you have to know the convolution summations. What is convolution summations? So first of all, we have to calculate the convolution summations for the continuous time input or continuous time system. This is basically uses for the impulse response x asterisk t, and this is also another function output of the yt and y asterisk of t. Okay, so this is basically it is called the convolution functions. Also using these convolution functions, this is basically train of the pulse transfer functions. You know that different values of changes, different ranges of the k, 0 to infinite ranges, it is also changes also. Okay, now this is basically summation of the these two equation, one of gt and xt. It is basically called the convolution theorem, convolution summations also. That is y of kt is equal to x of kt multiplied into gkt. Okay, this is the graphical form of the different t region. Okay, and another one, this is basically pulse transfer functions. This is a y of kt, and one function is g of function and x of kt. Okay, so we have to equation 1 we have to written here, that is y of kt, different value of ranges. Okay, is it clear, all of you?
Yes,
So
sir.
everyone, please write your own name and roll number in the chat box also. Pranav is present.
Yes, sir.
Take a screenshot